We're dealing with the subatomic particle in the atom called the electron. We talked about we can look at the different energy levels as we go down the left-hand side of the periodic table, going from 1 down to 7. We're adding additional rings to the nucleus of each of those atoms and add electrons onto those rings. The first inner ring can only hold 2. Each successive ring from what we're studying can hold 8, hence the octet rule. Each one wants to have 8. And the ones on the outermost ring of any atom are its valence electrons, and that's where all the chemistry happens. We saw how we could write an electron configuration address, the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6. And we showed that the electrons have up and down arrows to show which way they spin, or their north poles, and they like to spread across when they can and then pair up with opposite spins. And so now we're going to look at a fellow by the name of Lewis said, I don't want to draw all that. I like little dots. He says those I can do, because since it's the valence electrons, I'm going to use little dots to show how many valence electrons are with each of the elements, so I know how many can possibly react. So for the previous slide, we talked about the element hydrogen, the first one, in group 1, and it's on the first period or the first row, so it has one ring. And when we got that, we said 1s1. It's on the first period or first row. It's in the S block, left-hand side. It has one electron, which happens to be a valence electron because it only has one ring. So the scientist by the name of Lewis wanted to make it easier, so he developed, humbly so, calling it after himself, the Lewis dot structure. And he uses it to track the number of valence electrons an element has that potentially we can use to form compounds. And since hydrogen is in group 1, it only has one energy level, one ring, with one little lone valence electron on it. We saw from the periodic table, there's hydrogen. It's in group 1 on the first row. There's this little lone valence electron on that inner ring. So it's only got one ring. This shows 2, but hydrogen only has the one ring, and there it is. Lewis dot says we have a couple steps. Step 1, write the element symbol. So for a Lewis dot structure, hydrogen, that's its symbol. Write it. Next, using an up, down, left, right configuration or pattern. In this case, I only have one, so put it in the up position. So it's going to be above the symbol. You're done. That's what Lewis says. Say, hey, you give me that, I know you have one valence electron. Other atoms, there may be more. I don't care about those. I only want the ones we can do business with. Let's take a look at helium. Even though it's in group 18 on the far side of the periodic table, in terms of valence electrons, it should be over in group 2 because it only has 2 electrons. And it's still, like hydrogen, only has one energy level, one ring. But that ring has 2 valence electrons on it, not one. So there's helium in the periodic table. And for this case, we're going to move it over here where it's in group 2 because it has 2 electrons. And there's helium. I left the neutrons out on purpose. So we know it's helium because it has 2 protons. It's atomic number 2, so it has 2 protons. And since it's neutral, it has 2 electrons. And they both go on this first ring. That's the first ring. So it has 2 valence electrons. Lewis says, step 1, they are. Write the element symbol. Okay, Lewis, there you go. Step 2, using the up, down, then left, then right pattern, put a single dot starting in the up position and then move the next one down. So just like hydrogen, we put the first one on top, but since it has 2, we're going to take the second one, put it down below. We're done. That is the Lewis dot structure of helium. It says it has 2 valence electrons. Let's go to lithium. It's also in group 1, the first column, like it's below hydrogen, but it has in the second period, it has 2 rings. So the third electrons, remember the first one can only take 2, and it's got 3, so I got to do something with that third electron. It's going to go in its outermost ring. So there's lithium on the periodic table. It's in group 1, but it's got 2 rings. On its first ring, just like helium, it's got 2 electrons, but it's full. But since it's atomic number 3, it has 3 protons, making it lithium, but it also has 3 electrons because it's neutral. Well, what do I do with the third one? I put it on the second ring, the valence ring. There's where it goes. So it only has 1 valence electron. It has 2 core electrons, but you'll never get to those. There's not enough energy, but you can strip off or add to that outer ring. Lewis says, write the element symbol. There it is. And I have 3 electrons, so I'm going to use them. But I only have 1 in the outer ring, in the valence ring. So I only have 1 to put on. Yes, it has 3, but I only put the outermost ring's valence electrons. It only has 1. Just like hydrogen. It's in the same group. In fact, everybody in here is going to look like this with their own symbol. You're done. Let's pick one over in the P block. So nitrogen's in group 15, but it's also on period 2, second row, so it means it has 2 rings. Thus, it has 2 energy levels or rings, and actually has 2 sublevels, which we learned from the last lesson. So its last 5 electrons, remember if I got 2 digits, I cover up or ignore or subtract 10 from that. I get rid of the 1 since it has 5 valence electrons. So those last 5 electrons are going to be on the valence shell, the outermost ring. So step 1, write the symbol. Oh, by the way, here it is in the periodic table. There's nitrogen. It's in group 13, 14, group 15. So that's 5 valence electrons. And it's on the second row, second period. So it has 2 rings. There's this first ring, just like helium, just like lithium. The first 2 of its 7, because it's atomic number 7, so it has 7 electrons and 7 protons. The first 2 go on the inner ring, it's full. Everybody else goes on the next or outer or the valence ring, which means I have 5 left. That's where I put them. So we're going to use the up, down, left, right pattern with the single dots. So the first one goes up, second one goes down, third one goes on the left, fourth one, the right. Then I start over again. Those guys, like you saw in your 1S box lines the other day, they spin pair up. They have opposite spins. So these 2 are stuck together like powerful magnets. So even though I have 5, chemists soon found out only these single guys will pair up with something else. And that's going to be a coming lesson. That's where we're doing this. So there's the 5 that I showed you on the Lewis dot structure. And there they all are. You're done. I put in calcium. It's in group 2, so it's in second group, second column over, but it's on the 4th period. It has 4 rings. It's the last 2 electrons that it has are being the valence electrons in its outermost ring. So here's calcium. First ring can carry 2, there they are. Next ring can carry 8, there they are. Third ring can carry 8, it's full. The last, but I still have 2 left over, there's 20 electrons. The last 2, so 2 plus 8 is 10, plus 8 is 18. I've got 20. Calcium is number 20. 20 protons, 20 electrons. The last 2 will go on that 4th ring. So that's the valence ring. That one and that one. Step 1, write the symbol. Step 2, since I only got 2 dots, I'm going to put 1 on top and 1 on the bottom. And I'm done. And that's calcium. Because it's in the second group, it has 2 valence electrons. Lithium and hydrogen was in the first group, they have 1. Nitrogen was in the 15th, which means it has 5. It had 5. And we're